Okay, Charlotte Ann, you had a question about number 9. You have to prove if or tell whether AC is perpendicular to BD. Let me see. So if you see here, AC is perpendicular to BD. Remember, perpendicular means that the lines cross at a 90-degree angle. Well, we see AC is here, BD is here, and we see this little square here in the corner means that they meet at a 90-degree angle. So that is why that particular statement is true. Those lines do meet at a 90-degree angle because of the definition or because of the diagram. Yeah, Isabel, just a second. Let me pull it up. Okay, so if you see here, number 12, the measure of angle AEB plus the measure of BEC equals 180 degrees. So we're looking at the measure of AEB, which is this angle, and the measure of angle BEC, and we need to say if we know that they are 180 degrees. These two angles form a linear pair. We know that linear pairs are supplementary, and supplementary angles equal 180 degrees. We also know that this angle is 90 degrees, so therefore this angle would be 90 degrees. So that would make them both equal to 180 as well. Does that help, Isabel? Okay, good. All right, Megan, what's your question?
So for the conditional statement that we make out of the ad slogan, are we supposed to like explain why if it's true or false?
Yes.
Okay, and we also do that with the converse statement, right?
Yes.
Okay, thank you.
You're welcome. Okay, Charlotte Ann, so you need help with which part? Okay, so for number 21, your if then statement or your conditional statement is if a person is scuba diving, then the person is using independent breathing equipment to stay underwater for long periods of time. So that's the conditional statement. If we are going to figure out the converse, then we're going to switch it. So it will be if the person is using independent breathing equipment to stay underwater for long periods of time, then the person is scuba diving. So we have to say whether that is true or false. So if we know that they are using the equipment to stay underwater for a long period of time, and that is scuba diving, then that would be true. So the converse of this one would also be true. The inverse is going to go back to the conditional statement and make them both negative. So you're going to say if a person is not scuba diving, then the person is not using independent breathing equipment to stay underwater for long periods of time. And you have to determine if that's true or false. Well, if you are not scuba diving, then you are not using equipment to stay underwater for long periods of time. So that would be true as well. And then for the third part, the contrapositive is going to be take your conditional statement. Remember, we do the most junk to it. So take your conditional statement, flip it, and make it negative. So the person is using, or the person is not using independent breathing equipment to stay underwater for long periods of time, then the person is not scuba diving. So that would also be true. Does that help? Good, you're welcome. Number 8 on the 2.2 worksheet, Madison? Okay. Okay, so for that one, you are supposed to write the if-then form, the converse, the inverse, and the contrapositive, and tell whether each is true or false. So this says any 4 collinear points are coplanar. So if we think about that, the if-then form is going to be if any 4 points are collinear, then they are coplanar. Okay, so if any 4 points are collinear, then they are coplanar. And that would be true because if you have 4 points that are all on the same line, they are going to be all on the same plane as well. And then, let's see, we have to do, that's the if-then part. The converse is just flipping it. So we would say if 4 points are coplanar, then they are collinear. And that is false because if you think about that, you can have 4 points on a plane, but they are not necessarily all on the same line. And then for the inverse, if 4 points are not collinear, they are not coplanar because the inverse, we go back to the conditional statement and just make them both negative. So 4 points are not collinear, they're not on the same line, then they are not coplanar. And that's false because they could be on the plane, but on different lines going through the plane. And then contrapositive, remember we flip the if-then and make them both negative. So if your 4 points are not coplanar, then they are also not collinear. And that would be true because if they're not on the same plane, then they would not be on the same line. You're welcome. Okay, Lily, what does biconditional mean on the worksheet? Okay, so I told you guys in class that you would need to see, let me double check, I think it's page 74 in the book where it goes over what biconditional statements are. That will have the definition of biconditional statements, and it gives you examples too. So a biconditional statement is when its conditional statement and the converse are both true. For a biconditional statement, you would be able to say, this is true if and only if the other is true. So if you look at page 74, it says, it gives an example. If 2 lines intersect to form a right angle, then they are perpendicular. Well, the converse of that would be, if 2 lines are perpendicular, then they intersect to form a right angle. So your biconditional would be 2 lines are perpendicular if and only if they intersect to form a right angle. So then if you look at the worksheet for 14 through 17, you're going to use that. Rewrite the definition as an if-then statement, then write the converse of it, and then write it as a biconditional. So the midpoint of a segment is a point that divides the segment into 2 congruent segments. So if a point is the midpoint of a segment, then the point divides the segment into two congruent segments. So then for the converse, you'll flip those two. And then for the biconditional, you'll combine them and say a point is the midpoint of a segment if and only if it divides the segment into two congruent segments. Does that help some? You're welcome. Okay, Lily, for 9 through 13, you're going to have to look at the diagram, and this is going to be similar to some of those that we did on the Chromecast in class where I was doing the slideshow. So let me show you this. Okay, so for 9, if you look here, we have line AC is perpendicular. Remember, that means perpendicular to BD. And perpendicular means that two lines intersect at a 90-degree angle. So line AC and line BD, we can see that they do intersect at a 90-degree angle because of this little symbol right here. This tells us that angle AEB is a right angle. So because AEB is a right angle and the definition of a right angle is 90 degrees, we know that AC and BD are perpendicular. So you'll have to do that for the rest for 10, 11, 12, and 13. You'll have to look at them and see, you know, the definition of adjacent angles, you know, the definition of linear pair, and you'll have to apply that to see if those statements are true. Okay, for number 16, it says adjacent angles are two angles that share a common vertex and side but have no common interior points. So we are going to turn that into an if-then statement. There's no words in there that signify that we should swap the order that it was given to us in. So it would be if adjacent angles are two angles that share a common vertex and side, or sorry, if two angles are adjacent, then they share a common vertex and side but have no common interior points. So then you will go through that. You have to do the converse, which is going to be to flip your if and then. So it would be if two angles share a common vertex and side but have no common interior points, then they are adjacent. And then you would have to write as a biconditional. So it would be, let's see, two angles. Okay, Lily, number 13 and 15. So for this section, you're supposed to decide whether the statement is true or false, and if it's false, give a counterexample. A counterexample is an example that proves that it's false. So for number 13, it says supplementary angles are always linear pairs. I don't know if you remember back in class, we talked about supplementary angles and linear pair and the difference between the two. Supplementary angles could be one angle and another angle, but not together on the same line that add to 180, where linear pairs have to share that common side. So that one would be false. And a way to explain that would be to list a couple of angles with different letters. So like the measure of angle ABC equals 60, and the measure of angle GEF equals 120, where those two don't share any common side, but they are supplementary because they equal 180 degrees. Does that help with that one? Okay, and then for 15, if a number is a real number, then it is irrational. So for that, we would have to look up the definition or pull back into our knowledge of what the definition of an irrational number is. An irrational number is a number that, like pi is an irrational number. The decimal will go on forever and ever and ever. So if a number is a real number, then it's irrational. So you would have to also look at the definition of a real number. And a real number, let's see, an irrational number is a real number that cannot be made by dividing two integers or two numbers. So in that instance, then those are going to be false. And an example would be something like the number 2. 2 is not, it's a real number, but it's not irrational because it does not have a continuing decimal that goes on and on forever. Okay, I worked through number 16 with Charlotte Ann a while ago. Biconditionals are explained on page 74 of your book. Basically, if your conditional statement is true and the converse of your conditional statement is also true, then you can form a biconditional by saying this happens if and only if this happens. So both of them have to be true. So if you look at number 16, your conditional statement for that would be angles are adjacent, or sorry, if two angles are adjacent, then they share a common vertex inside but have no common interior points. And then the converse of that would be you would flip it. So if two angles share a common vertex inside but no common interior points, then they are adjacent angles. And both of those are true. So then for your biconditional, you would say two angles are adjacent angles if and only if they share a common vertex inside but have no common interior points. Did that help? You're welcome. Hey, Madison, I was just about to disconnect. Do you have another question? The symbol between line AC and line BD? Okay, that means perpendicular. You're welcome. I'm going to go ahead and close it now, okay?